CIT 1121, Module 7. 4 parts to Module 7, starting with Ethernet switching. We're going to start with the frames. We'll work into the MAC addresses, the MAC address table, and then the switching speeds and forwarding methods at the end. That's kind of like a cleanup chapter where they're like, hey, we forgot to talk about some of these other things that might be important. But the big concept stuff is really in 2 and 3. Stuff that's in 1 here, we get the Ethernet frames. We're going to define what we've been talking about in Chapter 6 or Module 6 to a greater degree, but it's not too much different. In fact, you're going to see some of these slides and the diagrams look pretty much exactly the same. So let's take a look at that. So what we got here is we got Module 7 Ethernet switching, and the very first part of that, 7.1 Ethernet frames. Now, we said data link frames before. We were talking about the idea of just frame headers. We're going to put a name on it. Now, the word Ethernet is really a specific technology. Now, what's great about Ethernet and what's great about this particular segment of talking about Ethernet frames is pretty much all the frames that you're going to deal with. Not all of them, but most of them are going to be Ethernet based. And we're really concerned about what's going on with our Ethernet frames, because if there's a problem on a local area network, chances are that Ethernet is going to be the overall technology that you're using to pass data back and forth between your devices, and Ethernet frame headers are things that you're going to want to look at, okay? So we're going to get very specific about Ethernet frames in this particular chapter. Now, this slide, hey, this looks a lot like something we saw before. There's our OSI model, and part of it's grayed out, and at the bottom, we're like, hey, the Ethernet frame's going to reside down at the data link and physical layer, and really it is the gateway into the network layer, and at the network layer, we can use any layer 3 protocol we want. We could use TCP/IP, we can use IPv6, we could use AppleTalk, we could use IPX. We could use all kinds of stuff that we're not going to use, but we're going to use is IPv4 or IPv6, and that's what we're going to spend most of our time on here. But we're going to go ahead and spend a little bit more time on Ethernet beyond this slide, and the next slide is going to look very familiar as well. And so, oh, hey, look at that. There's 2 parts to the data link layer, and we've got that. The picture here is a little smaller than we used before, but essentially, the job of the frame header is to set up communication between devices. So we're going to have a channel that's going to be developed. Now, the thing about Ethernet is it has a set channel. A wired Ethernet connection works with a specific frequency that all network cards are dialed into, so they can read that incoming stream of zeros and ones that's going to be electrically modulated into the wire as it passes along into the device. And so that's the first part of it. The second part is there's a procedure that goes along with that, and we'll get to that in just a second, but there's a procedure that needs to set up that connection. So you have to warn the device that you want to talk to that you're sending them data. That way they can differentiate between electrical noise and if it's actual data, just like humans do with their ears, right? So, you hear a knocking sound. That could be someone knocking at the door, but it could also be someone just knocking under a table or something. Or it could be something just fell off. Who knows? But you have to discern, is this valuable enough? Did this, what I just learned, what I just heard, is it valuable enough for me to change my behavior? Same thing is true of your network cards. And you can think of them as listening for electrical impulses. Are these electrical impulses that I'm receiving right now, are they just electrical noise? Is this just the offshoot of a microwave oven or a vacuum cleaner? Or is this actually another device that's trying to send me data information? And the devices have to discern by that. And the way that you do that is we're going to use a pattern of data that's going to go back and forth and tell the receiving device, hey, by the way, what's coming up next is a frame header. So we'll get to that section in just a smidge. But for here, this is exactly what we learned back in Module 6. The LLC sublayer, tell me what kind of packet header we're going to use. MAC sublayer, everything else. If there's encapsulation, if there's any authentication, it would happen here. If there's any encryption, it would happen here. The setup, it would happen here. Everything else, really. MAC address. Our MAC sublayer section is where we're at on that, okay? And that gets us into this piece, and this is, once again, this is a little bit of review. There is an Ethernet frame, and we're going to see what it looks like on the very next slide. So we're going to see the actual fields inside of that Ethernet frame, and we're going to have some kind of Ethernet addressing, and the addresses that we use within Ethernet are known as MAC addresses. The slideshows have been critical about not identifying MAC addresses until now that we're in with Ethernet, because they really do tie together. But the fact of the matter is, they were calling them NIC addresses before. I think that was just confusing. The MAC address value is the burned-in value, and we're going to get deeper into that in this section. Let's go ahead and move forward on that. And hey, here it is. There we go. So here's our slide. And it says the minimum Ethernet frame size is about 64 bytes, and the maximum is about 1,500 bytes. That's all that you can send. This does not include the preamble. The preamble is the warning that we were just talking about a few seconds ago, or it will not include the start of frame delimiter, which is the beginning of the actual frame itself. So when you look at this from here to here, if we're going from left to right, and we look at this PDU. This is a protocol, PDU, Protocol Data Unit. We got the whole thing posted right here. Now, here's the thing. This is not drawn to scale. Look at the numbers of what we have here. The preamble and starter frame delimiter. The thing that warns us is 8 bytes. The destination and source MAC addresses are 6 bytes each. That's 48 bits and 48 bits. That's not a lot of data. That's very, very little. And then the type field is only 16 bits. It's just 2 bytes. 2 bytes to tell the receiving device what type of layer 3 addressing it's using, what protocol we're using. Are we using IPv4? Are we using IPv6? And now look over here. Between 45 and 1,500 bytes. Now look at the size here. It's not drawn to scale. The size of this is exactly the same as the size of this. But in actuality, that's not really what's going on. This should be, if this was drawn to scale, this should go way, way off the page to the right before you get to the very end, which is the frame check sequence. And if you have a question on that, go back into section 6.3 and watch that video. That's just going to give us an error correction test on this, right? So this isn't really drawn to scale, but the important thing that we are pulling from this is the important pieces of an Ethernet header, of a very minimal Ethernet header. And if we were using the minimalist Ethernet header that everyone uses for wired networks, that format is called Ethernet 2 format, and we're going to look at that in Wireshark a little bit later. But it's called Ethernet 2, and it just has those main parts: source, destination MAC address, and a type field that you're going to use to identify what the layer 3 header is. That's it. Okay, good. That's about as far as I wanted to take this. Right now, we're going to come back and we'll do more on the MAC addresses in just a second.